Hello everyone, welcome back to TC online course on marketing and social media web analytics. I am T. Shiva, Assistant Professor from Department of Computer Science and Business Systems in Tyagaraja College of Engineering. In today's session, we are going to explore one of the most fascinating concepts in network science called preferential attachment, also known as rich get richer effect. This idea helps us to understand how networks grow, why some nodes become extremely popular, and how viral trends take off on platforms like YouTube, Instagram, and Twitter. Let's get started. So this is the progress of this particular course. So in the last video we have seen about the random graph network born in chaos. Now we are going to explore about the preferential attachment, the rich get richer effect. In today's lecture, we will cover what networks are and why are we study them, the difference between random networks and real-world networks, the Baer-Albert model, and the mathematicians of preferential attachment, few real-world examples including social media platforms, and case studies, problems, quizzes, and brief summary at the end. So what are networks? A network is a structure that represents relationship among entities. Each entity is a node. This could be a person, a computer, or a website. The connections between nodes are called edges. These can be friendships, hyperlinks, or communication links. Networks are used in many fields: computer science, biology, physics, economics, and of course marketing and social media analytics. By understanding networks, we can study influence, information flow, spreading patterns, and connections that drive digital systems. Types of networks. Networks appear everywhere around us. Social networks such as Instagram and Facebook connect people through friendship and following relationship. Information network like World Wide Web connect people through hyperlinks. Biological networks model protein interactions or neutral links. Technological networks include the internet backbone. Understanding these networks helps us decode the complex system. Random networks versus real networks. In early network theory, researchers assumed that connections formed randomly, but real networks don't work like that. Some nodes, like influencers or major websites, have thousands or millions of connections. Inequality cannot be explained by random choice alone. This is where preferential attachment becomes more important. Birth of network science. In 1999, Albert Lazlo-Barbeos introduced the idea of scale-free networks. This discovery revolutionized network science. He showed that networks grow through structure, process, and randomness. This mechanism explained why hubs extremely connected nodes exists in almost every complex systems. Preferential attachment concept. Preferential attachment means that the node with more connections are more likely to gain additional connections. In simpler, rich get richer. This explains why celebrities gain more faster and older websites have more backlinks, and why certain videos go viral. Why preferential attachment occurs? There are several reasons why the rich get richer effect happens. One is visibility. Popular nodes are easier to find. Trust. People follow what many others already follow. Algorithms. Social media platforms promote popular content. And cumulative advantage. Once you gain and early lead growth accelerates. This creates a snowball effect. Mathematical basis. When a new node joins the network, it connects with popularity proportional to degree. The formula is P of I equal to K of I summation of K of J. This means K of I is the degree of node I. Summation of K of J is the sum of degree of all the nodes. Thus, nodes with higher degree have the higher chance of getting new links. Barber's albatross model. In BA model, it has two principles. One is growth, another one is preferential attachment. Growth means new nodes join over time. Preferential attachment means new nodes connect to high degree nodes. This combination naturally gains hubs and leads to scale-free network. The growth rule. You begin with a small connected network. Each new node adds m edges and choosing existing nodes according to their degree. Over time, this builds a network where the degree distribution follows a power law. Let us see an example of this BA model. For example, consider nodes A, B and C. If node D arrives and has only one link, it will choose the node with the highest degree with highest popularity. This small advantages accumulates over time, turning early nodes into larger hubs. Real world evidence. This phenomenon is not theoretical. It matches real world data. Few websites receives the majority of traffic. Few social media users dominates follower count. Few scientific papers receives more citation. Wealth distribution also follows power law pattern. So these are some of the evidence in the real world for this rich get richer effect. Why celebrities explode online? Celebrities enjoy preferential attachment naturally. They have early visibility, media coverage, and existing fan base. Algorithms amplify their engagement. This ensures exponential follower growth. Scale-free networks. A scale-free network's degree distribution follows the power law. P of k cap minus tau. This means many nodes have very few connections. A few nodes have massive number of connections. This structure appears across social, biological and technological systems. Power law properties. In power law distribution, there's no typical degree. Most nodes are small, but the hubs dominate. This explains the viral nature of social networks as well as their robustness. Importance of hubs. Hubs act as shortcut in network. They reduce path lengths, spread information quickly, and maintain structural integrity. However, if hub fails or attacked, the network becomes unstable. Random failure versus targeted attack. Scale-free networks are robust to random node failure because most nodes are small, but they are extremely vulnerable to targeted attack on hubs. This insight is crucial for cyber security and infrastructure planning. Applications. Preferential attachments helps us predict viral market outcome, identify influencer for campaigns, model biological process like epidemics, understand economic inequality, design resilient systems. Criticism of BA model. The BA model has few limitations. It assumes linear attachment. Real network have clustering with which BA doesn't predict. It ignores node fitness or quality. In reality, nodes age or lose relevance. Fitness model. In fitness-based model, node have inherent attractiveness. For example, a celebrity automatically gains higher probability than an ordinary user with same degree. Fitness modifies the attachment probability to create more realistic networks. Non-linear model. These models assume attachment follow k to the power of a instead of k, where a, or we can call it as alpha, is greater than 1. Superhub dominates. When a is less than 1, the network becomes more equal. This reflects different real-world systems. Aging models. Nodes may lose attractiveness as they age. This explains why other posts get fewer views and new posts rise quickly on platforms like TikTok. Let's take a case study. On YouTube, creators who grow early gain cumulative advantage. The recommendation engine amplifies engagement. This creates a winner takes all ecosystem policy. In Twitter next also, the follower network, a few users hold disprominent influence. Retweet, cascades rely heavily on apps. Political campaigns exploit this to spread message quickly. Case study: World Wide Web Network. The web is directed graph. Some pages accumulate millions of backlinks. Preferential attachment explains why Google, Wikipedia, and network sites dominates the web traffic. So, problem solving example. Let's solve few quick example to reinforce this concept. Let's take the first problem. A node has 20 degree and the total degree is 200. So we have to find the probability of next node to connect to A. The probability of new node to connect A is equal to 20 divided by 200, which is equal to 0.10, which equals to 10%. So A has 10% chance of receiving the next link. The problem 2 is related to hub identification. In a network of 1000 nodes with average degree of 8, a node with degree 120 is clearly a hub since it exceeds 5 times the average. To summarize, preferential attachment explains why popular nodes grow rapidly. BA model combines growth and preferential section to form scale-free networks. Real-world systems follow power laws due to these mechanisms. This helps us to understand virality, influence, and digital marketing strategies. Alright, everyone, now that we have completed the lecture on preferential attachment and scale-free network, let us test our understanding with some short quiz. This quiz consists of 5 multiple choice questions, each related to the key topic we covered today. I will read each question, give you a few seconds to think, and then reveal the correct answer along with a brief explanation. Let's begin. In Barber's albatross model, new nodes connected to existing nodes based on dash. What determines the connection probability of BA model? And the answer is option C, node degree. This is because in preferential attachment, nodes with higher degree have higher probability of receiving new connections. This mechanism is what's called as rich get richer effect in networks. The second question. A scale-free network typically follows which degree distribution? The answer is power law distribution. In scale-free network, most nodes have few links and a small number of nodes have an extremely high number of connections. This pattern is exactly what the power law distribution represents. Next question. Preferential attachment is also known as dash. The answer is rich get richer effect. Preferential attachment explains how popular nodes get even more popular over time, creating a positive feedback loop. Next question. What's the main reason celebrities grow faster on social media in network terms? The answer is option C. Preferential attachment increase their visibility. Celebrities already have a large follower base, so algorithms promote them more and people tend to follow accounts that many others follow. This is clearly practical example of rich get richer effect. So the next question. In business analytics BA model, a node with higher degree has dash. Correct answer is option C. Higher chance of receiving new links. This is the core preferential attachment node. Nodes with more edges are more attractive to nodes, which helps them grow faster than others. So we have come to the end of this particular session. So we have explored about the preferential attachment, the rich get richer effect in this video. In the next video, we will see about the network growth and evaluation. Thank you for joining this 1 hour lecture, Preferential Attachment and Rich Get Richer Effect. This concept forms backbone of the many social media analytics insight. If you have any questions, feel free to reach out me. See you in the next session video. Thank you. Happy learning.